You are tuned to the Nagpur station of All India Radio. We now bring you to the talk on the subject Continental Drift Theory. The talker is Pranjal Anant Malgave.
Study of Earth, its composition, its structure, and the various processes occurring inside and on the surface of it. In our study, we have an important theory called uniformitarianism, which simply states that the present is key to the past. In other words, it can be said that the Earth that we see today is the result of natural laws and processes that once were being operated in and on the surface of the Earth. This theory was given by James Hutton, also known as father of modern geology. So to start the topic, we all know that the Earth is composed of three major layers: the crust, mantle, and core. Firstly, the crust, secondly, the mantle, and the third is the core. Crust is the first solid and silicate layer. Then we got mantle, which is viscous in nature. There is another important layer between crust and mantle, which is called as asthenosphere, which is also viscous in nature. Below mantle, we have an outer core which is less viscous than mantle, and finally there is a solid inner core. Today we are going to discuss about the continental drift theory. So, the continental drift theory in literal sense means the movement of continents. According to the history related to this study, it started with Abraham Ortelius in 1596. He was a cartographer and is also known as the creator of first modern atlas. So what he did was, he tried to compare and match the boundaries of the continents like North America, South America, Africa and Europe. And he found that they matched. The boundaries of the continents were symmetrical and equal in terms of their shorelines. Then in 1858, Antonio Pellegrini theorized the possibility of the continents to be once connected together. He did mapping for the coastlines of the continent and found that the plant fossils of America and Europe were identical, but no conclusion was drawn out of it. Later in 1912, Alfred Wegener came with the continental drift theory. He said that the continents that we see today were distributed over Earth's surface as individuals, but primarily connected together in the form of single supercontinent and surrounded by one mighty ocean. He named supercontinent Pangaea and ocean as Panthalassa. He said about 200 million years ago, this supercontinent started to split and it has broken into two major parts called Laurasia and Gondwana land. Laurasia moved towards the regions above equator, while Gondwana land moved towards the region below the equator. Now to support his theory, he has given evidences like the jigsaw fit, meaning the continents that were adjacent to each other matched each other's coastlines. For example, South American and African coastlines matched. Secondly, he talked about same rock at the same time. Each rock have its own composition and he found that the rock detected at the boundaries of adjacent continents were of identical composition and ages. His third evidence were the placer deposits. If to be discussed in short, the gold deposits of Ghana in Africa are the placer deposits, but the rock responsible for the formation of gold are not found in Ghana. On the contrary, they are found in Brazil, in South America, which again tells us that Africa and South America must have been together at some point of time. Our fourth evidence are the tillet deposits, which are specifically the glacier deposits. In areas like Australia, Madagascar, Africa, India, we have found such tillet deposits. But how can there be glacier deposits in area of such high temperatures? Himalayas and Antarctica have glaciers, but they have their own special reasons for it. Otherwise, no glaciers can be found in such high temperatures. This creates the evidence for our verification that these continents must have been together. Our fifth and the strongest evidence are the fossils. Fossils provide an hard evidence on such matters. Fossils like Mesosaurus, Glossopteris, Gangamopteris, lemurs, and many more, which are the mammal and plant fossils, were found in parts of the world where their being is almost impossible. Another example of this can be seen in the case of oceanic fossils found in Himalayas. Now, as we know that it is impossible for an ocean to reach the level where we see Himalaya today at such great height, which again draws our attention towards the continental drift theory, that the land that is over Himalayas must have been beneath the ocean at some point of time and gradually moved towards the height due to the various tectonic forces. Now, how did the continents actually fall apart? There are many reasons, out of which in the beginning were presented are like the pole fleeing, meaning the movement of Laurasia towards northern region or equator and the movement of Gondwana land towards the regions below equator. These forces are generated due to the rotation of the earth. Secondly, he gave tidal force, meaning due to the gravitational forces of sun and moon, the continents must have been broken and dispersed over the earth's surface. But these primary reasons were not convincing enough, so he gave more solid reasons to justify his theory. Primarily, he gave conventional currents. The radioactive elements in the mantle decays and generates heat, which ultimately outbursts in the form of mantle plumes and tears the crust apart, and makes room for the fresh lava to cool down to make new crust, also pushing the continental boundaries simultaneously. This is the actual reason why the continent separates from each other. Secondly, he gave seafloor configuration. After World War II, countries like USA started exploring oceans. What they found was the seafloor was not at all uniform or plain in nature, but it had mountains, trenches, and very uneven surfaces. Another interesting thing that they noticed was the oceanic crust was younger while the continental crust was older. Also, the oceanic crust was thin, that is almost 5 kilometers or so, while continental crust can range from 30 to 60 kilometers widely. While this oceanic exploration was done, they found something more interesting than just uneven surface. At oceanic depths, they have found mid-oceanic ridges. These are some parts of oceanic crust where the new magma is being generated, which falls out of its depth. When it cools down, then by default it solidifies and makes rooms for more magma, simultaneously pushing the existing load. In this way, the movement of plates over the Earth's surface happen. There are also regions where the plates are undergoing each other. These zones are called subduction zones, where one weaker plate goes under the denser plate, and when it slides down, due to the extreme heat, the plate starts to melt, and in this way the new plates keeps on forming and the older one keeps on disappearing or melting. But in this whole series of events, a natural question arises that where was our India and what was its position? So to begin, I must tell you that about 80 million years ago, Indian plate was primarily a part of Gondwana land. After significant millennia years later, it detached itself and moved with the Australian continent. Now, about 50 million years ago, India detached itself from the Australian plate and gradually moved and bashed over the Eurasian plate. But it happened so that due to the identical densities of both the plates, they did not subduct under each other at all. But instead, they formed the world's highest mountain range, the Himalayas, out of which Mount Everest and K2 are some of the highest peaks in the world to name. Himalayas have many oceanic fossils, and it has the world's oldest and biggest whale fossil, dating back to 42.5 million years ago. So this is how the continental drift occurs in our nature and will continue to happen. So let us explore and see what happens.